Hello? Test. Okay. We have only 10 seconds, so I'm going to take a picture. So give me your hands and smile. Oh, okay. Maybe there's a picture on Twitter. I assume the picture has been uploaded to Twitter. Yeah. Okay. Pretty cool, huh? As you can see, there's no wire. All the streaming data is transferred to my computer in air. And so how can we apply this to our daily life? Well, you can do whatever you want, but be careful. Don't break the law. Yeah. Interesting. So I'm going to turn off my camera. And whoops. So, 皆さんこんにちは。Hey, it's me. Me. My name is Jian Weihang. It's Chinese name. And username is Tony Jian. And in Japanese, maybe you pronounce Tony Jian. That's right. And you can find me in most of our major websites using this ID, such as Twitter, Facebook, GitHub, Google, and you can add me. And by the way, I have nothing to do with Tony Chopper. When the first time you use this ID, One Piece haven't created yet. Okay. I'm the founder of Brandana.com. It's an e-commerce and website outsourcing company using Ruby on Rails. And I'm also the co-founder of 5 Times Ruby. And it's also a Taiwanese company. And it is established in May this year, very new. And as you can see from the name, the company is literally a company based on Ruby. Our business includes courses and trainings of Ruby and Rails. We also offer technical consultancy to enterprise. The ultimate goal of our company is to let programming language of Ruby to be broadly utilized in Taiwan. Other than that, I'm also a coach of Rails Girls Taipei. And I won the first place in Yahoo Hackday Taiwan last year. My main expertise are Java and Ruby. Yep. Besides, I also play music. As you can see, there's a keyboard behind me in the picture. I'm a double keyboard player, but there is only one layer of keyboard. But where's another keyboard? Another keyboard is on my laptop. Double keyboard player. Taiwan, here, small island. So let's come back to the main topic for today. I would like to talk about Sony camera remote API and how I use Ruby to control the camera and handle streaming. This topic is not as difficult as it looks. Streaming processing can sound a little bit hard, but I won't go too deep in this talk. Take it easy. I'm telling you a story. So let's go back. The story begins from 3 months ago. I was very lucky to be assigned a project. It is a project regarding Taipei City New Recreation Center. As you can see, it's a playground for kids with 5 hectares wide and plans to open up in the end of this year. There are a total 13 different facilities in this recreation center, including the Ferris wheel, turning cups, free fall, and flying bus ride. However, today I'm not here to talk about architecture. I'm here because one of the facilities called Photo Truck needs a program to control the camera. This is how the photo truck looks like. And And from the appearance of it, you can see there's a huge camera lens. Most of parts of this car is not my business. I'm only in charge of only two things: and the camera and the screen. Yep. And in this project, I was asked to control the camera and the monitor with this flow. First, a short film is played on the monitor. Then the live preview on the of the camera is displayed. Next, a picture will be taken, and the picture is freezed for 5 minutes before it repeats from the step 1. But this is not all. We also need to add some small components on the screen. For example, the shutter countdown on the upper right hand corner during display the preview, and as well as the screen size countdown should be shown 3 seconds before the shutter takes the photo, the right side. Yeah. And this is how it looks like. People stand this place and will take a picture. And I have no idea what this giant creature from the day I got this project until I finished it. And it's probably a huge crab, I think. Okay, here comes some solutions I found which can probably solve this problem. The first solution to display. And the first solution bumps into my mind is the VLC API. With this, we can easily control the video over TCP connection. For example, when to stop or when to play. Even the volume can be controlled as well. And the good news is there is already a gem called a VLI client. Yep. Nevertheless, it'll be a big problem when we want to add some effects to the film, such as count images and sound exactly. It's impossible to add such an effect. We need to hack. It meant me to choose another way to approach, and I found an HTML5 could be a better alternative of VLC. What have only changed is to use JavaScript rather than Ruby. So another problem is how to control camera. This second problem, usually when asking for a solution to control camera, the first thing can be the library GPhoto2. It supports more than 1,800 cameras and both provide command line mode. But it didn't work as I expect. Of course, GPhoto2 can easily command a camera to take photo or record a video. But when it comes to live preview, there's no corresponding API to do this. We have to repeat capturing preview photo again and again. This way is lack of efficiency and elegancy, and I don't like it. And second, it's always surprising. For example, once I invoked an API to take photo, it crashed, and I'm surprised. And luckily, when I tried it twice, the second time, it worked again. However, after I tried the third time, it crashed and surprised me again. So far, I don't know what's going on. What I have done is just repeat the same movement 3 times, and yeah, surprising. So, fortunately, I found a savior, and it could be the best solution ever. It's Sony remote camera, not Tony remote camera. Sony remote camera. This is one of the camera. This one, DSC QX100, what I use. So how's this camera? Is there any advantage? First, it's free. You pay nothing to get their SDK, and it's open also. And second, it's easy to communicate through Wi-Fi and a common protocol such as HTTP and UPnP, and it's open as well. And besides, it's easy to call API by HTTP post request with one of the most popular data formats in the world, JSON. Besides, it's open. And finally, it's well documented, and it's open. And if you wonder why I repeat it's open for 4 times for each line, because It's very important. Why? And you know, many digital camera manufacturers refuse to share their camera communication specification with users, and that's a big pity. And without this, we can hardly make applications for cameras. G-Photo 2 was created for this, but it's a reverse engineering software just like Weihang. You know how Weihang is, right? and Sony opens its camera API recent years and probably is the only one who did this. Thanks, Sony. So how to access the camera? There are only 3 steps. Connect the Wi-Fi, and second, discover this device description file, and then call API through HTTP post with JSON data. If you are a web developer, you probably have understood the first and the third step, and especially I'm not going to explain how to do the first step in this talk. Okay, discovery. How to discover device description file. Let's begin the second step. As the graph shown, you can see there are 3 steps: 2.1, 2.2, and 2.3. And any camera supporting the camera remote API can be discovered using SSDP. And the formatting is familiar to HTTP, but a little bit different. And as the graph shown, we send an mSearch request to get the location of the device description. Then we can send another GET request to download the device description file, which stores all information of this camera, including API URL. And that is to say, when we turn on this camera, it's an access point. And when we connect to this camera, it's a HTTP server. For example, this is how it works. I've mentioned SSDP is similar to HTTP. And here it sends a request with an mSearch verb. And note that the fields such as host and mandatory and search target are all fixed value in this case. Yeah. And if you receive the response successfully, you got a device description file URL. It's an XML. And once you download it, you can get API URL and invoke them. And maybe you can pass it by NoCoGIDI or ReXML, whatever. And in this case, the API URL is /Sony/camera. Okay. So how's the API? The API is implemented in JSON RPC. And it's a remote procedural call protocol encoded in JSON, just like XML RPC. It's very simple since there is only 5 types of attribute defined. You can see it's method, parameters, ID, result, and error. Yes. Note that ID is a value which is used to match the response with the request that it is replying to. So they should be the same in the request and response. But in my opinion, on account of that, HTTP is designed by request-response pattern. So I think ID field can be totally useless, yeah, in Sony's API. So here's an example for how to take a picture. The method is act take picture, and response is it returns a JPG file URL. And zoom in, act zoom. Parameter is an array in and start. And set exposure. The API provided by Sony is very diversified. Besides the basic function of taking photos and recording, there are more than 90 functions, including lenses, zoom and out, aperture, white balance, picture quality, exposure mode, and also preview. So Ruby time. So how to integrate it with Ruby? First, we have to store a request header in a variable, mSearch. Second, you send this request via UDP, waiting for the response to get a device description file URL of your camera. Of course, you can simply parse it by regular expression to get the location. DMSI, yeah, there's a long URL. And once you get a URL, API URL, you can invoke an API call, and that's all. But know that it's JSON RPC, so we must store the JSON string in the request body. We are not passing web form data here. Okay. But how about live preview? It makes a little difference. First, for live preview, there is a method called start live preview without any parameters, and it will return a streaming URL. You have to continue download this file. The package data format is like this. The live preview data is downloaded as one data stream by HTTP GET, but the encoding is designed by Sony rather than any other well-known protocol. The smallest unit is called packet, and as the diagram indicates, during the download, this packet will be repeated again and again. And the client should keep on downloading the data of packet and extract JPEG image from the packet and decode it and show it on the screen. Okay, and here's more detail about packet format. And here comes the first 8 bytes is common header, and then following is payload header for 128 bytes. Okay, I'll just skip it here. Ruby time. The problem is how to extract data from a binary stream. So here's the Ruby code of how to get an HTTP response chunk by chunk. And this code is borrowed from Ruby official document. But in this case, we have to do something special to decode the packet. So we need a buffer to do this. If the buffer is empty, retrieve the next chunk. Otherwise, keep processing the data in the buffer. And here I'm going to introduce you this method, string unpack. Well, there are so many Rubyists in the world, but few people knows about this method since when it comes to processing binary, they used to using C language rather than Ruby on account of the speed issue. But Ruby is also I think Ruby is also good and even more easier for processing binary. You don't need too much effort to do this. Yeah. And the code, what is unpack? Unpack method decodes string, which may contain binary data according to the format string, and returning an array of each value extract. For example, let's take a common header for example. And as I just mentioned, there are 8 bytes in common header, and some of them are numbers, sequence number and timestamp. Yeah. And we assume that the common header is stored into the variable called common header. After we call unpack, we got an array with 4 elements. So the question is, what is AANN? Here's a cheat sheet. A means an arbitrary binary string, and N is a short integer. And if you turn to uppercase, it becomes a 22-bit unsigned integer. And go back to see this slides again. And the first A means the start byte, and the second A extract the payload type. Third, N will extract a sequence number as an unsigned integer, and the last uppercase N is the timestamp. So we can easily get a 4-element array and extract sequence number and timestamp. That's how it did. Okay, and another example. Let's talk about payload header. Payload ではない. Payload. Okay. So it's a payload header, 128 bytes in payload header, and what we are truly care about is the second field, JPEG data size. If we don't know JPEG data size, we may mismatch the packet and the streaming is it will be broken. And it's a 3 bytes unsigned integer number. However, there's no integer which is 3 bytes. We got a 1 byte char, and 2 bytes short, and 4 bytes integer, and 16 bytes a long type. But there's no 3 bytes integer. In this case, I made some difference to do this. It's a H6. But before that, I would like to explain what is A4. A4 means arbitrary string, but A4 means it will decode for 4 bytes length arbitrary string. As you can see, the first element, A4, is start code, and it's 4 bytes length. And H6 will return here. H is a hex string. So here, H6 means it will return a 6 length hex string. And if you are familiar with Ruby string to the method of hex, then you can just call the hex method to turn it to a number. Yep. And the last one, A, and following star, we'll treat all remaining string as arbitrary string because we are not care about the reserved part from 9 to 12 and the flag and and all the other bytes in the end. So, and that's all how to process the binary. And you may ask, is there any Ruby gem to do this? Yes, there it is. It's called TonyCan. No, Sony can. It's in my repository. If you are interested, you can maybe give me a start. Okay. The Ruby usage can be a bit complicated at first glance, so I recommend you to use the command line version. After doing these 3 commands, you're supposed to take photos successfully without configuring anything or knowing about your IP address. And the second command is Sony scan. Should be used only once and the first time at the first time to discover your camera. So yeah, here are all commands I announced so far. The most notable one is the second last command, Sony Live View. And it will print streaming data to standard output. On the other hand, you can easily pipe it into your application. For example, to record a live preview into an MP4 file. If you're familiar with FFmpeg, you can simply do a command like this. Yeah, pipe to FFmpeg. Or you would like to use this camera as an IP cam. You can use FF server and FFmpeg to pipe it to live streaming. Okay. Here are some friendly reminders. First, there is a secret in DSC RX100M2. There are several types of cameras of Sony which supports camera remote API. But one of them, RX100M2, I don't know why there is no Sony in its API URL. Maybe this camera is probably not made by Sony. I don't know. But this secret is not mentioned in any official document. So if you bought this camera and you don't know how come why you cannot call the API, maybe you have a wrong URL. It's a bug. And second, the mandatory extension field. Please add a double quote in the mandatory field since the official document forgets to do this. Yeah. Even the UPnP spec document mentioned this, but Sony document didn't. So there are some friendly reminders. And conclusion. First, Sony's camera can friendly be for Sony's camera are friendly for developers. Yeah. though there's G402, but G402 is a reverse engineering. And second, Ruby could be a bit slow than C, but it's easy to write, even handling binary. As you can see at the first time I show you this camera, I read the gem in Ruby, and the FPS can up to 50 or 60 FPS, so it's not too slow. And okay, and that's my talk today. Thank you.
There is few minutes for question. Does anyone have any?
Okay, so in your application that you showed, it's a stream of JPEG images that just constantly comes, right?
Yes, JPEG images.
Yeah, and you said that you are using a web browser to display on that.
Oh, yes.
Yeah.
So what is your question?
Okay, so you also said that you are overlaying some information on in that the park application. You are overlaying something on top of the images, right?
Of the top image. I don't know.
It counts down, and then it takes the image, and then it displays the image with an overlay, right?
Oh, it's a div tag, and I uploaded it using JavaScript. Actually, the stream there is a Sinatra server on my computer, and I'll show you again. Yeah. Oh.
Okay, so that countdown is just a div, in other words.
So the countdown is I wrote it in JavaScript to control this camera. Okay. Also, and there's a API server. It's written in Sinatra. So streaming. This camera is also a HTTP server, so that I can call it from a call API from.
Okay, so you're not actually processing the stream with something like OpenCV or something like that, and then compositing the numbers on top of that. You're just
I just decode the format that Sony gave me.
Okay.
Yes.
Okay.
Yeah. So.
Okay. The time is.
Oh, okay. Lunchtime.
Hi. Thank you very much, Mr. Jian.